Hello students. So solenoid. So what for the problem solving tricks? How do we solve the problems based on solenoid related question? Okay. So what is exactly meaning of this solenoid? Solenoid is when a large number of wire, a number of turns, when large number of turns are made wrapped over non-conducting cylinder. That non-conducting cylinder, it may be hollow, it may be solid, no issue for that. Okay, so large number of copper, insulating copper wire. Okay, so this is what it's a when large number of turns of insulating copper wire, okay, is wrapped around over a cylinder. A cylinder can form, that's what solenoid. So just basically, if you think about, for the solenoid here, when I use this is what, like a, so anyone, so is the cylinder. Okay, so for this cylinder, when you go on it here, it's a cross section means what, like this. Yes, is the cross section the case, right? So next one here, just one second. Next one. So if I'm choosing the axis, this is the axis. It's a axis. Is the axis. These are the, now is wound over this coil. Okay, like this. The current is passing through the coil like this. Number of turns are N. Yes. So this is a solenoid. Say solenoid is like N number of turns are wrapped over it. Okay. N is the total number of turns. Total number of turns. And small n is what? Number of turns per unit length. Number of turns per unit length. N is equals to capital N by L is the relation. Total, for example, let's say 2 meter. 2 meter means what? 200 centimeter. Over this 200 centimeter, how many number of turns are distributed? Let it be 20,000 turns. In 200 centimeter, 20,000 means in 5 centimeter, how many turns there? In 5 centimeter, how many turns there? So calculation that number of turns per length gives what? Small n. Total number of turns gives what? It's a capital letter N. Now, so for this one, the magnetic field induction at this point, any one point, I'm choosing this is what? So I'm taking like, okay, so is the solenoid. Yes. So this is the solenoid. Now the axis is taken like at this point. Okay, so what A, this is the, yes. So this makes an angle with the x-axis. This is the axis. This is the axis. With this axis, with this first end, it makes an angle θ1. Next one, with the second end, if you see, this is the second end where you want to find the field here. So this angle is with this axis, again I am saying with this axis, this is what theta 2. Okay, left side is negative, right side is positive. Okay, so the magnetic field induction theta 1 and next theta 2, for all the problems we can calculate in this way. Okay, magnetic field induction at this point O, otherwise P, I am saying this, it's a P. So magnetic field induction B is equals to mu naught Ni, small n, you can see mu naught Ni by 2 times of cos theta 1 minus cos theta 2. So this is the magnetic field induction, okay, due to this solenoid. So only the keyword is you need to remember. So its derivation and all the things you can know that. But how do you solve the problems using this solenoid methods? So here is the point from where this is the axis. From this axis, this first angle is what? Theta 1. Next, this is what it said, theta 1. Next one is what it said, theta 2. P is equals to mu naught Ni by 2 times of cos theta 1 minus cos theta 2. Okay. So for example, if you want to talk one by one. So for example, if I am taking as very first one. Okay. So a solenoid is taken. This is the solenoid. Yes. So now, if I am taking as this is the axis at this point, here is the center. Center means now I am taking it infinite. Okay. Infinite solenoid. So infinite case means what? Here this is, first one is, for example, this is A and next one is, it's a point B. Okay. So infinite is what? This is the axis. So is the infinite. Infinite means the angle will become as what? First one is what? It should be like from here to here means this one. From here to infinite means what? Like this. Means first one theta 1 is equals to 0 degrees. Next this side infinite means what you write? So this angle is what? Like this. So what is the angle? Theta 2 is equals to 180 degrees. Okay. So magnetic field induction B is equals to mu naught Ni by 2 times of cos theta 1 0 degrees minus cos 180 degrees. So you know cos 180 is minus 1. So B is equals to mu naught Ni by 2. Mu naught Ni by 2 times of cos 0 is 1, minus of minus plus, it's a 2. Okay, 2 and 2 cancel. Magnetic field induction inside on the axis of the solenoid. Okay, so that we can treat it as an infinite. So B is equals to what do you write? Mu naught Ni. Okay, N is the number of turns. For example, if you take about any one end, for example, if I talk about second one, at the end, okay, at the end. This is what, like, here is taken, it's okay, like is the end. So this is one end is this, here is the end. So here is the axis. Semi-infinite also we can take for all the cases. One thing you remember, sometimes he won't give the angles, he will give the length. Then how can you calculate? So by the trigonometric ratios we can find it. So first one at the end means what? This is very first one, here only. This is first end, this is the second end. So what is the angle? So this is what? 90 degrees. Okay, so this is what? Second one is what? Like this. For example, this is a line joining. This is what? This is the angle. So theta 1 is equals to 90 degrees and theta 2 is equals to theta if you say. So then B is equals to, we can write mu naught Ni by 2, correct? Mu naught Ni by 2 times of cos theta 1 cos 90 degrees minus cos theta 2, it's a theta, like we can write this. So for all the cases, any some length, so for example, if this point is given, if you want to find the length, lengths are given, if you want to find the angle, so cos theta 1 and cos theta 2 angles find and substitute the equation. So the basic information is what this. So which formula? B is equals to mu naught Ni by 2 times of cos theta 1 minus cos theta 2.